Welcome back to Java programming class. Today we are going to see delegation event model. We are going to see what is this delegation event model, which are the different components of delegation event model, and how this has been implemented in AWT and Spring applications. Before we learn about delegation event model, let's look at what is an event. When we build a GUI-based application, a GUI application will contain different components. The components could be a text box, could be a list box, could be a checkbox, could be a set of buttons. And the user who are using our application interacts with these GUI components. When they interact, we say that they have performed some action on these GUI components. In programming, we take this term as event. So, an event is an action that is initiated by the user while interacting with our GUI program. We know very well that user can have many different types of interaction with our application. However, all of them are not really necessary for our program. So, when we talk about event is an action or an occurrence that is identified by our program and has some significance for our program or for the hardware system. Not everything or not every action that is performed by the user need to be treated as an event. Some of them, even though they belong to an event, they may not be considered as event because they don't make any sense to our application. Now, which are those actions which can be treated as event? So, event can be user generated, like typing something on a text box, clicking at some place within your application, or an event could be system generated, like loading your program, running your program, or your program has terminated. All of them are events. So, in general, when we talk about GUI programming, event is nothing but an action. So when you interact with any component of the GUI, you in turn generate an event. We are all familiar with algorithm-driven programming. So far, we have studied many algorithms and we have created many applications or programs that run on these or that are based on these algorithms. So all these programs generally do one common thing. They start and they accept data input in a predetermined format, and then they perform the steps which are there in the algorithm in a fixed interval of time, and then finally they return the result. To give you an example, I have a program here that finds the greatest among 5 numbers. Now, this algorithm that I am using is a very trivial algorithm, which is not a great algorithm as such. But just to give you an idea how the algorithm programs really work. So I execute this program, and as usual, this program will start and it will accept some input. I'm going to type the input. So I have typed all the input, Now, when I give the input to my program, it will perform the steps which are there in the algorithm and finally return the result. Now, you notice that there are much less interaction in this kind of programming. However, the application that we are developing now are GUI based. In these applications, we have a very different scenario. Suppose if the same type of application is created using GUI, then you notice that there are a lot of interaction. So the user can type a number, user can click at some other place and type a different number, even though we are supposed to provide some number over here. And then user can type, they can remove some number, type something else, and then they can click on the buttons to get the result. Now you notice that this is much more interactive as compared to the plain command line based applications. So let's come back to the PowerPoint now. What is event driven programming? It's a style of coding in which the overall flow of the program is dictated by the events. Whereas when we talk about algorithmic programming, the overall flow of the program is predetermined by the algorithm that you have written. The program starts, accepts some numbers or accepts the input data, performs the algorithm, and then returns the result back to you. Whereas when we talk about GUI based application that we have seen here, now this program starts and waits for the user to make or to interact with the GUI component. And which button I have clicked or what type of action that I have done with this component will determine the flow of my program. So that is what is event driven program. So event driven program starts and waits for an event to occur. By the way, let me remind you again that event is an action that is performed by the user. So your program starts and waits for an action by the user. The action could be clicking on a button, selecting some items, clicking, dragging, or any kind of action that you can expect on a user interface. Based on the event, your code will run. So the program runs, the execution of the program solely depends on the event or the sequence in which the event has occurred. Okay, so thus the overall flow of the program is determined by the series of events that occur within the program. Now suppose if we want to write an event driven program, what are the things that we are supposed to do? So whenever an event occurs, so for example, whenever somebody clicks on some components which are there on the GUI, what are the things that we are supposed to know? So there are basically three things that you must know. What type of event that has occurred? That's the first thing. For example, the event could be clicking on a button, selecting an item from a list, clicking on a checkbox, selecting an item from a menu, or it could be any other type of action that the user has performed. So different actions means different type of event. Okay. So our program must know what type of event has occurred. Next one, you may have many components within your program. Now when an event occurs, you must be able to pinpoint from which component the event has originated. In other words, which component originated that particular event. That is required in order for us to handle a particular event. So if I know which button is clicked, I can take the appropriate action. First, I must know what type of event has occurred, whether it is a click, whether it is a double click, whether it is a drag. So what is that event? Which component generated that event? And when an event has occurred within a particular component, what is that I am supposed to do? That's the next thing. So if you know all these three pieces of information, then we can think of writing programs to handle the events. Now the question comes, we are using Java. So how can we handle these three particular things? So let's start with the three basic questions that we are supposed to know. First one, what type of event has occurred? Next one, which component originated that event? Next one, who is going to handle or who is going to get the notification of that particular event? Fortunately, when an event occurs, the Java virtual machine recognizes that event, and it's going to tell or notify our program that a particular event has occurred. So we don't need to bother about the occurrence of the event. As the user interacts with our application, they may click, they may select, they may do something with our GUI application. Whatever that action that the user has taken, the Java virtual machine, that is JVM, will recognize that action and will notify our program about that action. Now suppose there are two buttons are there here. Somebody clicks on this button. So two buttons are there and somebody clicks on this particular button. So the JVA is going to tell me that the button has been clicked. Now it is my duty to find out which button has been clicked. So how do I know that thing? When the JVI notifies me about that event, it's not going to just tell me that a button has been clicked. Along with that click event, it's going to give me additional information. Now by looking at that additional information provided by JVM, I have to decide which one originated or which one created that particular event. Next thing is, once I know which button has been clicked, I have to take appropriate action for that particular event. Okay, so this is again my responsibility. However, I can tell the JVM, in particular, I can code it in my Java program to handle the event and take appropriate action for the event that has occurred. Now let's come back to our agenda, and our agenda was, what is event delegation model? What is it? Okay. Event delegation model defines a standard and consistent mechanism to generate and process event. So what is the meaning of it? Java provides us with the consistent mechanism to handle and process the event. So there is already a built-in model that the Java follows, which is much easier and which is much robust as compared to the other non-standard methods. So when we are dealing with AWT or when we are dealing with Swing application, there is a standard way of handling the event. And this standard way of handling event is nothing but event delegation model. So here the Java people have provided you with this standard method, okay, which is consistent. That means to say that any type of GUI you build, regardless of your type of application that you are talking about, the steps that you have to take to handle the event are all standard steps. And it is consistent from one application to the other application. So what is there in this particular model? So in this model, there are two important components. One is the source. The second one is the listener. Source is that component that generates an event. For example, a source could be a button which is there on your form. So when you click on that button, it generates an event. This event is sent to the listener. So source is the one that generates an event. An event is the one that listens to, the listener is the one that listens to that event and takes the appropriate action. So the work of the listener is to wait until an event occurs. And when an event occurs, perform the particular action and return the control back. For example, I have my application here which is running. Now, when I click on this particular button, an event gets generated. So this acts as a source of event. When I click on this button generates an event and sends that information to the listener. So what does this listener will do? Listener will listen to that event, gets the event from that source and performs the required calculation. In my case, I was trying to find the greatest among these 5 numbers. So it's going to perform all the calculation that are required to get the result. However, there is one small twist to this whole thing, and that is not every listener will listen to every event. In order for a listener to listen to a particular event, it must register itself with the source. So when you click on a button, the button will generate an event, and this event is given to only those listeners who have registered with that button. Not everybody will listen to that particular event. To give you an analogy, we know that in our home we have this paper wala who delivers paper during morning. Now this paper wala will not dispatch paper to you unless and otherwise you have subscribed for it. So what's the first thing that you are doing is you go to this paper wala and you tell the paper wala that I want Indian Express to be delivered to me every day. So this is nothing but you are registering with the source. So when an event occurs, and what is this event? Tomorrow morning or next day morning, a new paper comes. So a new paper is printed. When the new paper comes, an event is fired. Okay. So this event goes to the paper wala And because we have subscribed with this paper wala, he is going to deliver that event to our home. Our neighbors may not be interested in reading newspaper. In that case, they will not receive the newspaper. So even though they have the capability of reading the paper, they will not get it because they have not subscribed to the newspaper. So the idea is very simple. Only those listeners who have registered themselves with the source will receive the event when that particular event has occurred. So the next question usually comes, can we have more than one listener? The answer is yes. So a source can have multiple listeners registering with it. So when an event occurs, all the listeners will get the notification. At the same time, if you are not happy with the Indian Express, you want Times of India, you can then tell your paper wala that I want to cancel my subscription, I want to change my subscription, or I want to remove the subscription. That is also possible even with the Java coding. So a listener can register itself with the source, or listener can unregister itself from the source. What do I mean by saying unregistered is that, so if the listener is not interested in listening to a particular event, so it can go to a source and say that please unsubscribe me or unregister me, I will not handle this kind of events anymore. So that is possible. And this idea is being used in delegation event model. Now let's look at a simple example how it really works. So let's assume that I have a button here which I can click. So when I click on this particular button, the button generates an event. The reason for that is button acts as a source. And that event contains an information. So I click on this button and the button generates an event. This button will deliver that information to the listener. So the listener will take that particular event, which is provided by the source, and then based on that particular event, it performs the required task. So this is as simple as that. So we have a GUI which takes up the action or which takes up the event, and we have a listener that performs the required action. And you notice that both of them are well separated. So we have a separation between the GUI component and the event handler. So that is an advantage of this particular model. So what's the advantage of delegation event model? The advantage over here is the logic that processes the event is separated from the user interface logic. So I can build a good looking GUI and I can separately build the event handling logic without intermixing them and cluttering the programs. So I can reduce much of the clutter in my programming by separating these two things and only having a loose couple between these two elements. And which are those two elements? One is my user interface, the other one is the code that handles the event. In a very simple way, I can say that the user interface element delegates the processing of events to a separate piece of code that is handled by the listener. Now coming back to the Java coding. So how does all these things work in real Java code? So when we write a Java code, the event handling works as follows. First, we need to have a source which must register all the listener object that is interested in a particular type of event. And when that event occurs, the source must create a event object. Source must create this event object and deliver this event object to all the registered listeners. And what are the listeners supposed to do? So listeners are supposed to get this event object, and then based on the information which is there in this event object, call an appropriate method to handle the given event. So this is the way in which event handling works within Java. So now let's look at the first thing. So I've told you that the source generates this event object. So what is this event object? Let's look at that first. So an event in Java, we know very well, everything is either a class or an interface or a package. You don't have anything else apart from that. So an event, when we talk about Java programming, an event is a object. Okay. So when I say that event is an object, this is derived, or this is instantiated from a given class. So event is something that is an instance of some class. Which is this class? We'll look at it slightly later. So we know very well when we talk about Java, we need to know about classes, interface, and so on and so forth. So event is a object. What does it do? It describes the state change in the source. So when I click on a button, when I make some selection, or when I click on some of the component, its state changes, and that is what is described within that event object. So to take a simple example, let's look at this checkbox over here. So you notice as I click, its state changes. It is now checked, and when I click again, it gets unchecked. So the state of that particular button changes, and that is what is described in an event. Let us consider one more example. Now I have a drop down list over here. When I select an item, the selected item changes. So you notice that I'm able to select one item. Maybe I'm able to delete or do something else. But you notice that when I make a selection for an item, the item that is selected changes. Same thing if you look at the action that I can think of performing on a button is I can click on the button and some action I can perform. All these things indicate that there is a change in the state. So when you click on a checkbox, its state changes from the checked to unchecked, or from the unchecked to check. Or when you make a selection of a particular item from the list, the selected item state changes. Suppose if I select this one, the selected state of this particular drop down list changes. So this change is described in the event object. So the event object describes a state change in the source. When does the state of a given component changes? The state changes when the person interacts with these elements. So when I click on something, when I make a selection using my mouse, or when I type something on a text box, all these are nothing but I am making a change in the state of the given component. So some of the activities that can cause the events to be generated is pressing the mouse button, typing something on a text box or a text area using keyboard, selecting an item from the list, clicking using mouse is also a change of state. So that itself generates a event. All these things are because a person or a user is interacting with the component. However, the event can also get generated when nobody is interacting with it. When does that particular thing can occur? So I have a counter over here, and when this counter becomes 0, that means the timer has expired. Now when this counter becomes 0, I can have a event getting generated. You have all visited the petrol station. So you are suppose you are putting 1 liter of petrol. When the counter value starts from 0, 1, 2, 3 and so on, when it comes to the 1 liter value, when it exceeds your petrol that is coming out of that pump will stop. Why? Because an event has occurred. So when the counter exceeds a particular value, you can generate a event. Same way, there can be a floating point exception or some runtime exception that can happen. In that case also a event just gets generated. However, we treat that event as an exception in a different way. An event can also occur when a particular hardware failure occurs. Event can also occur when some operations are completed. So for example, your program or your module has performed something, it can fire a event saying that I have completed some work. Now you can take this idea of event still further and you can define your own event. For example, if you are writing a program for handling student management system in your college, there are many events that are appropriate for that particular application. For example, when a user or when a student pays the fees, you can think of firing a event. So this is an event. When a student writes an examination, that is also an event. So event, you can think of an event as an object that describes some change in the state of the component. Now in our case, We are only interested in the GUI component, but you can take this concept to any level. Now, next part of event delegation model is the source of this particular event. We know very well, source is also an object. So it could be a button, it could be a checkbox, it could be anything that generates the event. When the event is generated, the event gets generated when the internal state of the object changes. So when the user interacts with the particular component, its internal state changes, which forces it to generate a event. Now the other thing about our source is that a source can generate more than one event. For example, using the mouse, I can move the mouse. I can click and drag the mouse. So I can do that. So when I press a button, there can be event button pressed. That means I am pressing the button. And when I release that button, there can also be an event saying that button released. So two events can occur. For a given source, it depends on the source, a source can generate more than one event. So it is possible. Other property of the source is that it must have a method for registering the listener. So that is very important. Whenever a listener comes to the source will make a note of all those listeners who are registered with the source for a particular event. And when that event occurs, all those who are registered for that particular event will be notified by sending a copy of the event object. The last part, which is part of event delegation model, is the listener. Again, listener is an object that gets a notification when a particular event for which it has registered occurs. So we must understand a few things about it. So event listener has two major requirements. First one, it must have been registered with the source. So if you just create a event listener and keep it, nothing is going to happen. Unless and otherwise, this event listener is registered with the source, nothing will happen with that particular event listener. So it's just creating a event listener does not mean that it will start listening. It will listen to only those events from only those source with which it has registered. The next part about it is, once it receives a event notification, it must have a method to take care of that particular event. So it must implement the method that knows how to receive an event and process the event notifications. Let's look at this in terms of Java. So let's assume that I have a object here. Let's assume that I have a object here called source. I have an object called listener, event listener, and I have an object event. How does it all work? The first thing is, in order for an event listener to listen to a particular event, it has to first go to the source, and then the source has to register that listener. That's the first thing. Let's assume that our source is a button. So user interacts with this particular button by either clicking on it or by taking some action on this particular source component over here, this will activate a event. So when a user clicks on this button, what's going to happen is the source is going to generate a event object. So it's going to create an event object that describes what is the change in its state. That information is placed in this particular event. This event object is then delivered to the listener, provided that listener has already registered with the source. So all those event listener which have been registered with the source will receive the event. Now what does the event listener will do? It will get that event, and then based on the information which is there in that event object, will handle that particular event. Now, in order for us to do programming in Java, we must know few of the classes which are required in event delegation model. The first class that we need to know is the event class, which plays a very important role in event delegation model. So what is this event class? So there are many event classes are there. So event classes are those classes that represents event. For different events, there are different classes are there. So remember, not all the events are same. Clicking on a button is a very different event than clicking inside a checkbox. This is a very different. Clicking inside a list box is also a different event. So depending upon the different types of events, we have different event classes. So Java has provided some core classes that handles the event. All these classes starts from event object, which is the base class for all the events. Remember, this is derived from java.lang.object. We know very well in Java, any class either directly or indirectly gets inherited from object class, which is an obvious thing. So I will not show up that particular thing. It's already there. So because I'm talking about event, for me, the root now is event object. This is the class from which everything begins. Now where is this class found? The event object class is found in Java util. So it is there in the utility package. It acts as a superclass for all the different types of events that can occur in your programs. So the event related to the text, event related to selecting of an item, event related to typing something on a keyboard, event related to the mouse related activities, event related to the button click and kind of activity, all of them somehow directly or indirectly are inherited from this base class, and that is the event object class. So all the event class are taken from this base class, and that is the event object. However, when we think of a GUI component, for us, even though event object is the base for everything, for us all the events are derived from AWT event. This is the class. So AWT event is a class from which our GUI related events are inherited. So it acts as a superclass for our GUI component. What about java.util.event object? It's a base class for everything. So I told you the events are not just with the GUI component. The events can be there for any other things also. For your application can have its own personalized events. For example, when a student writes an exam, you can consider that as an event. When a student completes a course, you can consider that as an event. So when you write an exam, events, your state changes or the application state changes, then events get created. However, that event is different from the event that I am talking about. I am talking about the AWT event here. And why I am talking about AWT event here? I am talking about all the components which are there in your GUI, the button, the text box, and all of them are GUI components. The events related to these components starts from AWT event. So it starts from here. Okay. So it acts as the base. You must notice one thing, as a Java developer, you must notice one thing. This is available under java.awt. So the previous one was available under utility. This is available under a separate package, java.awt.awt event. Now to code these events, you must know what are the meaning of them. So you notice here, there are many events are there. When to use these events, because they are different and their actions are different. You must know which is the event that you are handling. I will give you a brief overview of the different event classes, because it is not possible for me to explain each and everything in depth, because it's going to take hours together explaining about each and every event classes. You can always refer the textbooks, or you can go to the Oracle's Java sites to get in-depth information about different methods and different parameters that you can use among these different event classes. I will only explain which one is to be used in a given situation. Before we proceed, you must understand that all these classes are again found in java.awt.event. So you don't need to, if you are using NetBeans, you don't need to bother about all these things, because NetBeans will take care of these package importing statement. However, it is a good startup practice to know where are those packages and where are those classes and how these classes are spread across different packages. Let's start with the few of the most commonly used event classes. The first one is the action event. The action event is generated when you click on a button. So when you have a button, when you click on the button, the action event occurs. In the same way, if you have a list of items, suppose if you have a list of items, if you double click on any of the items, action event occurs. Now you may be wondering, when is this list and so on and so forth. All of you are using Windows, and in Windows when you double click on when you click on my documents, there will be many documents which is there in my document folder. To open any of them, you just double click on it. So what is this my document? My document is a container after all, which contains many items. You double click on one of them, and that double click is taken care as action event. So for a Java program, if you are writing a Java program, when you double click on a list of items, you get action event. Same thing is true when you have a menu. Suppose you have a menu like this. If I select an item from this menu over here, the event that gets generated is the action event. Next one is the adjustment event. Now adjustment events are associated with scroll bar. Just to give an idea, I have the scroll bar over here. You can notice I will just show it over here. So I have the scroll bar, which you can see here. So this scroll bar, when I move this scroll bar up and down, okay, and events get generated, and that event, so when I click on the up arrow, down arrow or something, when I do something, you notice that things are changing. Okay, when this thing happens, the event that gets generated is the adjustment event. Next one is component event. Component event occurs when the component is moved, resized, becomes visible. So you have a component over here. Now, let's assume that I am running this program, so I am not going to close this particular thing. Now when a particular component is resized, so I've shown you different types of layout there. So let me try to spoil this whole thing by changing the layout to say a flow layout. Okay, things you notice that things are there, it's going to appear very differently. Now as I move this particular thing, and you notice that things are changing, so the components are moved, components might have been resized, you notice that. Okay, so size might have changed. So when all these things happen, an event occurs, and that event is nothing but component event. When you move it, when you resize the component, or when the component is visible or it is hidden, when this kind of thing happens, the event that you can get is the component event. Next one is the container event. So container event occurs when I add a new component into the container. Okay, so we know that if I add a text box, remember it is not the one that I'm talking about, this kind of thing. So you have your NetBeans here. Okay, I'm going to just bring it back to the free design over here. Now the things are it's all gone, so I think I can undo this thing. Okay, so let me drag a text box here, and I put the text box here. Now I am putting a new things over here. This is not going to create a event. Remember why I am designing it. So during the designing, no events are going to fire. When you run the application, and in the program, if you are adding a new component over here, that time the event is fired. So don't think that events will fire if I use the NetBeans and then drag one component and place it there, then I will get an event. You will not get the event. So events happen when the program is running. So at runtime, if you add a component or if you remove a component from the container, you get the container event. The next one is focus event. When a component gets the focus, then we say that we can have the focus event. I'm going to show you the example. So now the focus is on this text box. If I click inside the other text box, the focus is there on the other text box. So if I click on this text box, I get a blinking cursor over here. That means the focus is on this one. So just to highlight, the focus is there on the other component. Now you notice it's a very easy. So in Visual Basic you might have done. So component in, I'm moving out of it. So you get a focus. So when a component gets a focus, you can notice that it is blinking. So it gets a focus, it loses the focus. So this is called as getting a focus. Okay. So when a component gains a focus, you get the focus event. The next one is input event. Now you must notice one thing. I'll just take you to the previous slide over here. And if you notice at this junction over here, you have this input event. From the input event, there are two events which are generated. One is the key event and the other one is the mouse event. Both are derived from the input event. So input event is not directly used. Instead of that, we use key event or mouse event. Both are derived from it. So now back to the place where we have stopped. So let's go to the input event. Now input event is an abstract superclass for the other input like key or mouse event. It's not directly being used, but it acts as a superclass for the other type of events. Then we have the item event. It is related to selecting an item in a checkbox or making a choice. And if you have a menu where you can make a selection, then you can have it. So I don't know whether I get something here, whether something is highlighted or not. So it is not. I'm going to just take you to my desktop over here, and then I'm going to show you that thing. You notice that you have a icon here, you have a menu here, and it is not checked. So auto arrange, I click on it. Again I go back. You notice this time when I go here, it is auto arrange is checked. Can you see that? Now if I again select it, it becomes unchecked. So this kind of a menu item is called as a checked menu item. And when you have those, you can have item events. Next comes is the very simple one, key event. And the key event is when you click on a text box and when you start typing, so you get keyboard input. Whenever a keyboard input occurs, we get a key event. The next one is the mouse event, and the mouse event is has to do with the mouse movement. So you can drag the mouse, you can click on the mouse, press and release the button, and all these events are handled, are there with the mouse event. Text event is when you change the value within the text area. For example, if I go to my program and go to this text box and I type some value, or I make some changes to these values, an event gets generated as the values are getting changed, and that event is the text event. The next one is the window event, and this window event occurs when the window is activated. closed, deactivated. So we are all familiar that we have the window here. Okay. When you maximize this window, minimize this window, reduce the size, all these things, a event occurs, and that event is the window event. Even when I quit the window, that event occurs. Let's look at other type of class that we are supposed to know, and that class is the event listener. Now we are all familiar, event listeners are those classes which receive the notification from the source. Now all these listeners must receive the notification and must perform some standard operation. So in order for them, or in order to restrict them to have some methods which are standard, which are consistent, what the Java has done is, any listener that you are thinking of using must somehow implement some standard interface. You know very well, interface is a contract, and any class that takes up that particular interface has to implement the abstract methods which are there in these interfaces. All these interfaces are available in java.awt.event package. There are different methods which are there. Whenever an event occurs, the appropriate method in the listener is taken up, and the event object which is generated by the source is passed as an argument to this method. As usual, there are different types of event listeners are available. For different scenarios, different event listeners are available, and as usual, the list goes very large, and I will not be handling all of them. Now, this particular website I have already shown you. This is the website, you can always visit that. So here what these gentlemen have done is they have created an application that will show you the hierarchy. Now right at the top over here is all event listener have to somehow directly or indirectly implement event listener. This is available under java.util.event listener. So this is an abstract interface. So event interfaces are always abstract. Okay, this has to be implemented by the other type of event listener. I'm going to just click on action listener. So action listener, okay, is going to do many things. Okay, it has some constructor and so on and so forth. So what does it do is this is an interface. Any class that implements that particular interface, that is action listener, can be used as an event listener. So suppose you want you are writing a class in Java and you want this class to be a listener. What you are supposed to do is it has to somehow implement either one among them. One of the interface has to be implemented by your class, then only you can call that class as a event listener. Not any class can become event listener. So let's look at some of the standard event listener classes. First one is the action listener. Now this has only one method to receive the action event. When does the action occurs? When you click on a button or when you make a selection from a menu. Action listener can be used to listen to these events. The next one is the adjustment listener. We are all familiar. So why do we use the adjustment event? Adjustment events are used with the scroll bars. Naturally, when you make some changes in the scroll bar, if you want to handle that change in your program, then you have to create a class that will implement adjustment listener. There is again only one method that you need to override. Next comes the component listener, which is part of the handling the component. So when a component is added, when a component is removed or resized or shown in a container, and you want to take some action, in that case create a class that is going to implement the component listener. This particular interface will have 4 methods for the 4 actions, and you will have to override all the 4 methods. Next comes container listener. Now this is used when you add a component or when you remove a component from the container, and there are 2 methods corresponding to this action, adding and removing. So if your class is implementing container listener, you will have to override those 2 methods. Next comes the focus listener. This focus listener has 2 methods. One is when the component gains the focus. Other one is when the component loses the focus. Next listener is the item listener. There is only one method that you need to override. Now this has to do with the state changes, in particular the checkbox. When the checkbox is clicked or when it is unchecked. So only one method you will have to override. Key listener, it has 3 methods depending upon the key you are pressed, key is released, and key is typed. Now I would like to add only one extra thing. When you press a keyboard, suppose if I press the key A from my keyboard, so when I press the key, the pressed key gets generated. When I release that key, the released events get generated. These 2 actions, pressing and releasing, that action together is called as typed. Typed means you have typed that letter altogether. So when a key is pressed, you can handle that event. Now you may be wondering why on earth that these 3 events are there. Now you know very well, sometimes you hold control and drag, sometimes you press shift and then press the other key. So you need to know whether you were holding the shift key when you are performing the action. So did you press the shift key or control key or some other key when you performed that action? Okay, so you must know that thing. So whether a key is pressed or not, how do I know that thing? I can always go to this event. So if the key was pressed, then you may take some action. When the key is released, you may take some action. Or when both the action pressing and releasing occurs, you may take some action. Based on that, there are 3 methods are there. Now let's go to the next one, and that is the mouse listener. Now you know very well, using the mouse you can click it. Mouse can enter a region, so your mouse can come into a region, so it can enter a particular region, or it can come out of a region. Okay, you can press the key, or you can release the key. Again, 2 things. Holding the mouse button down is pressing it. Releasing it is again a different event. So you have all those events. There are altogether 5 events are there for that. Again, we have very different type of event listener, and that is called as mouse motion listener. So this is used when you are dragging the mouse or when you are moving the mouse. For example, I am moving the mouse. As I move continuously, mouse motion events get generated, and if you want to listen to that particular thing, then you will have to have mouse motion listener. Where do we use it? So you are used MS Paint for drawing something or Photoshop for drawing something. So as you drag a line appears in Photoshop or in Paint, how does that happen is you have this mouse dragged event that is being listened by those programs. Next, let's look at the other event listener, and that is the text listener. Now this is used when the value of the text changes. So when you change the value of a text box or text, this event fires. We also have the window listener. It has 7 methods based on when the window is activated, deactivated, closed, iconified, de-iconified, opened or quit. Now you really didn't get it. I will just show you a simple scenario here. So you have this window. So this window, if I minimize this, that is called as iconified. So from the minimized, if you click on it, it comes back, and that is called de-iconified. So iconified is minimizing it. Again, from the minimization, if you are getting it back, it is called as de-iconified. Opened, you know very well. Quit when I close it. Quit and close is a very different thing. Close means this particular window is closed, but your application is not at quit. Okay. Similarly, activation, the window comes into picture. Okay, that activates and deactivates when it goes back. So there are all these events which you can think of using in your program. That's all for today. We will see how to develop the programs in Java to handle events in our next session. Thank you.